There's something hauntingly beautiful about the night sky, the way it stretches endlessly, dotted with stars and galaxies, each holding secrets we're only beginning to unravel. But what if I told you there are patches of cosmic fog out there, drifting silently through space, that don't just obscure light, they bend it, twist it, and play tricks on our telescopes, all without the gravitational pull we'd expect from such a phenomenon. These aren't black holes or dark matter. These are cosmic fog clouds, and they are some of the most baffling structures in the universe. Imagine a mist so strange it acts like a lens, distorting the light from distant stars in ways that shouldn't be possible. Scientists have stumbled upon 27 of these enigmatic formations, each one a puzzle waiting to be solved. What makes these cosmic fog clouds so extraordinary isn't just their ability to bend light, it's the fact that they do it without any detectable mass. Gravity, as we understand it, shouldn't allow this, and yet here they are, defying the rules and leaving astronomers scratching their heads. Some theories suggest exotic forms of matter we've yet to discover, while others propose entirely new physics at play. One thing's for certain, these fog clouds are rewriting the textbooks, forcing us to question what we thought we knew about the fabric of space itself. This isn't just a story about distant cosmic oddities, it's a reminder of how much we still have to learn. Every time we think we've figured out the universe, it throws us a curveball like these light-bending fogs, humbling us with their mystery. So join me as we journey through these 27 cosmic anomalies, from their accidental discoveries to the mind-bending theories trying to explain them. By the end, you'll see the night sky a little differently, knowing that even in the vastness of space, there are still wonders waiting to be uncovered. Let's dive in. The first of these cosmic fog clouds, dubbed the Phantom Veil, was spotted in 2018, and it immediately stood out as something unlike anything astronomers had seen before. Stretching an incredible 200 light-years across, this vast, ghostly structure doesn't just drift passively through space. It actively warps the light from galaxies behind it, bending their images into strange, stretched arcs, a phenomenon usually caused by the immense gravity of massive objects like galaxy clusters. But here's the catch: the Phantom Veil doesn't have nearly enough mass to create that kind of distortion. Hubble's Space Telescope images reveal an eerie, mist-like glow surrounding the cloud, but traditional explanations fall short. Dark matter, the invisible stuff thought to make up most of the universe's mass, could be at play, but even that doesn't fully account for the sheer intensity of the lensing effect. Some researchers wonder if this cloud could be a remnant of a colossal cosmic collision, a ripple in space-time left behind by an event so violent it warped the fabric of reality itself. Others suggest an even wilder possibility, a previously unknown form of energy, something beyond our current understanding of physics, lurking within this ethereal structure. What makes the Phantom Veil even more perplexing is that it doesn't behave like ordinary interstellar gas or dust. Most cosmic clouds scatter or absorb light, but this one bends it with pinpoint precision, almost as if it were designed to distort our view. Could it be a natural lens, a cosmic accident formed under rare conditions? Or is it a glimpse into a deeper layer of the universe's workings, one we're only beginning to uncover? Either way, this phantom of the cosmos has become a beacon for astronomers, drawing them deeper into the mystery of these light-warping clouds and the secrets they might hold. While the Phantom Veil left scientists questioning the nature of gravity itself, the second cosmic fog cloud, known as the Whispering Haze, takes the mystery even deeper. Nestled near the Andromeda Galaxy, this eerie formation doesn't just bend light, It seems to communicate, emitting faint, irregular radio pulses that defy conventional explanation. Imagine standing in a thick fog, hearing whispers you can't quite decipher. Only these signals are coming from the depths of space, flickering in and out like a cosmic Morse code nobody can translate. What sets the Whispering Haze apart is its chaotic light distortion. Unlike the Phantom Veil's precise lensing effect, this cloud scatters and warps light unpredictably, as if some unseen hand is tugging at the fabric of space itself. Traditional models of interstellar matter can't account for this behavior. Gas and dust clouds typically absorb or reflect light uniformly, but the Whispering Haze treats light like a funhouse mirror, twisting it in ways that leave astronomers baffled. Some theorists point to cosmic strings' hypothetical cracks in spacetime left over from the universe's birth as a possible culprit. These ultra-thin, incredibly dense defects could, in theory, warp space around them, creating the haze's erratic distortions. Then there's the radio signals. These faint pulses don't match the rhythmic emissions of pulsars or the steady hum of background radiation. They're irregular, almost deliberate, sparking speculation about quantum fluctuations, tiny, spontaneous changes in energy at the smallest scales of the universe. If true, the Whispering Haze might be a rare window into quantum mechanics playing out on a cosmic scale, where particles flicker in and out of existence, warping the space around them. Others cautiously suggest we might be seeing the fingerprints of something even more exotic, a form of energy or matter that operates outside our current laws of physics. What's undeniable is that the Whispering Haze forces us to rethink how light and matter interact in the void of space. It's not just bending the rules, it's rewriting them, leaving scientists with more questions than answers. Could this be evidence of a deeper layer of reality, one we've only begun to glimpse, or is it a natural phenomenon so rare that we're witnessing it for the first time? Either way, this whispering enigma reminds us that the universe still holds mysteries beyond our wildest imagination. The Luminous Mirage isn't just another cosmic oddity, it's a full-blown optical illusion on an interstellar scale. Floating through the Perseus cluster, this enigmatic fog cloud takes the mystery of light bending to new heights, creating not just one but multiple warped reflections of galaxies behind it. Picture standing in front of a funhouse mirror, except instead of your reflection, its entire galaxies stretched, duplicated, and twisted into surreal shapes. And here's the kicker, there's no massive object nearby to explain it. No hidden black hole, no dense cluster of dark matter, just this shimmering, prism-like haze defying everything we know about how light travels through space. What makes the Luminous Mirage so baffling is how closely it mimics the behavior of a mirage. On Earth, mirages occur when light bends through layers of hot and cool air, creating illusions of distant water or floating cities. But in the vacuum of space, where temperatures are more consistent, this kind of refraction shouldn't happen, yet the mirage does it effortlessly. Its refractive index, the way it bends light, matches no known interstellar medium. Some researchers speculate it could be filled with an exotic form of plasma, one that interacts with light in ways we've never observed. Others wonder if we're seeing the fingerprints of higher dimensions, where the fabric of space-time folds in ways our three-dimensional minds can't easily grasp. Then there's the duplication effect. Normally, when we see multiple images of a single galaxy, it's due to gravitational lensing, a massive object warping space-time to create cosmic echoes. But the Luminous Mirage pulls off this trick without the necessary mass. It's as if space itself has developed a flaw, a wrinkle that splits light into fragments like a broken mirror. Could this be a sign of quantum foam, a theoretical froth of space-time at the smallest scales, somehow manifesting on a cosmic scale? Or is it evidence of something even stranger, like a parallel universe brushing against our own, its presence subtly distorting our view of the cosmos? One thing's certain, the Luminous Mirage doesn't just challenge our understanding of light. It forces us to reconsider the very nature of space. If something as seemingly simple as a fog cloud can warp reality this dramatically, what else might be hiding in the shadows of the universe? Every new observation peels back another layer of mystery, revealing just how much we've yet to learn about the cosmos and the invisible forces shaping it. The echoing mist isn't just bending light, it's playing tricks with time itself. Nestled in the Virgo supercluster, this fourth cosmic fog cloud behaves like a celestial echo chamber, capturing starlight and bouncing it back to us in delayed, distorted fragments. Imagine shouting into a canyon and hearing your voice return seconds later, stretched and warped, except here, the canyon is a vast interstellar haze, and the echoes are beams of light that have traveled millions of years, only to stumble through this enigmatic fog and emerge changed. What sets the echoing mist apart is the way it seems to slow down spacetime within its boundaries. When astronomers first noticed the lag in its light patterns, they assumed it was a glitch. But the delays were consistent, as if the cloud were stretching the very fabric of the universe, creating pockets where light moves at a crawl. Einstein's theory of relativity tells us massive objects can warp time, but the echoing mist does this without the gravitational heft of a black hole or a galaxy cluster. It's as if the cloud has its own rules, a hidden physics we've yet to decipher. Some researchers speculate the mist could be threaded with cosmic filaments, invisible strands of dark matter or energy that twist spacetime like tangled threads. Others propose a radical idea, that we're seeing evidence of quantum entanglement on a macroscopic scale, where particles within the fog are so deeply linked that they alter the passage of light collectively. Then there's the unsettling possibility that the echoes aren't random. Could the delays follow a pattern, a kind of cosmic code waiting to be cracked? A handful of scientists have even floated the idea of temporal turbulence, ripples in time itself, left over from the universe's violent birth. One thing's clear, the echoing mist forces us to confront the fluidity of time in ways we never expected. If a cloud of cosmic fog can hold light hostage, bending not just its path but its very rhythm, what else might be possible? Could there be regions of space where time flows backward or loops in on itself? The mist doesn't just challenge our understanding of the cosmos, it invites us to rethink reality itself. And with every new observation, the mystery only deepens, leaving us to wonder if we're glimpsing a flaw in the universe's design or a feature we've yet to comprehend. The silent abyss isn't just another patch of cosmic fog, it's a cosmic paradox. While most of these mysterious clouds bend or scatter light, this fifth anomaly does the unthinkable. It swallows light whole, leaving behind a perfect void in the tapestry of the night sky. Telescopes trained on this region capture nothing but an eerie, starless blankness, as if someone carved a hole straight through the universe. But here's the twist: unlike a black hole, which devours light with crushing gravity, the silent abyss exerts no detectable pull. It's darkness without mass, a shadow without a source, and that's what makes it so unsettling. At first glance, you might mistake it for a simple dust cloud, the kind that dims starlight by blocking it. But the abyss doesn't just obscure light, it extinguishes it completely. Photons vanish the moment they cross its boundary, as if slipping into a realm where the laws of optics don't apply. The strangest part, there's no afterglow, no residual heat, just cold, silent absorption. Scientists have a name for this in quantum field theory: negative energy. It's a hypothetical state where the energy of a region drops below even the vacuum of empty space, creating a sort of anti-gravity effect. If the abyss truly harbors such energy, it could explain why light doesn't just dim here. it disappears without a trace. Then there's the shape. Most cosmic fog clouds drift in irregular, wispy formations, but the silent abyss is unnervingly precise. Its edges are sharp, almost geometric, as if carved by some unseen force. Some researchers wonder if it's a cosmic defect, a tear in the quantum fields that underlie reality, like a wrinkle in spacetime frozen into permanence. Others speculate it could be a shadow cast by something far stranger, a parallel universe overlapping with our own, its presence only detectable by the absence it leaves behind. But perhaps the most haunting question isn't what the silent abyss is, it's what it means for our understanding of darkness. We're used to thinking of space as an endless sea of light and shadow, where darkness is just the absence of stars. But this void challenges that assumption. What if some patches of the cosmos aren't just empty? What if they're actively swallowing light, hiding secrets we can't even begin to fathom? The abyss doesn't just defy explanation, it dares us to rethink the very nature of nothingness. And until we crack its code, it remains one of the universe's most profound mysteries, a silence so deep even light can't escape it. The Fractal Nebula doesn't just bend light, it sculpts it into art. Floating near the edge of the observable universe, this sixth cosmic fog cloud is unlike anything else in the known cosmos. Instead of warping starlight into chaotic smears or gentle arcs, it twists beams into intricate, repeating patterns like a snowflake magnified to celestial proportions. Every time astronomers zoom in, they uncover another layer of geometric precision, as if the nebula were built from an infinite cosmic blueprint. And that's the puzzle. Nature doesn't usually create fractals this flawless, especially not on scales spanning light years. What makes this structure so mesmerizing is its mathematical purity. On Earth, fractals appear in fern leaves, coastlines, and even lightning bolts patterns that repeat at smaller and smaller scales. But these arise from simple, iterative processes like erosion or growth. The fractal nebula, by contrast, displays a complexity that defies natural explanation. Its spirals and branching arms aren't just similar, they're near-perfect copies, echoing across vast distances with eerie symmetry. Some researchers suggest it could be the aftermath of a hyperdimensional event, where higher dimensional physics left behind a shadow in our three-dimensional space. Others wonder if we're seeing the imprint of a quantum field frozen in time, its vibrations crystallized into visible form. Then there's the tantalizing question of purpose. Could these patterns be accidental, a rare confluence of cosmic forces, or is there something more deliberate at work? A handful of theorists cautiously propose the nebula might be a kind of cosmic antenna, structured to resonate with specific frequencies of light or energy. If true, it could hint at phenomena we've yet to imagine, perhaps even a natural communication network woven into the fabric of space itself. Skeptics counter that it's simply a stunning coincidence, a Rorschach test on a galactic scale. But with each new observation, the Fractal Nebula seems less like an accident and more like a riddle waiting to be solved. One thing's certain, this celestial artwork challenges our assumptions about randomness in the universe. We're used to chaos, exploding stars, colliding galaxies, the messy birth of planets. Yet here, in the depths of space, sits a structure of breathtaking order. Whether it's a message, a monument, or just a quirk of physics, the Fractal Nebula reminds us that the cosmos has a flair for the unexpected. And as we unravel its secrets, we might just discover that the universe has been speaking to us all along, not in words, but in geometry. The celestial mirage doesn't just defy expectations, it plays an interstellar game of hide and seek. Unlike the other cosmic fog clouds that linger in one place, this seventh anomaly flickers in and out of existence, popping up in different corners of the sky like a ghostly cosmic will-o'-the-wisp. One moment, it's bending the light from a distant quasar into surreal loops. The next, it's vanished without a trace, leaving astronomers scrambling to confirm they ever saw it at all. This isn't just a cloud, it's a cosmic illusionist mastering the art of disappearance. What makes the celestial mirage so maddening to study is its refusal to follow the rules. Most astronomical phenomena, even the bizarre ones, adhere to some pattern or rhythm. But this cloud operates on its own erratic schedule. It might materialize near the Orion Nebula for a few weeks, only to reappear months later in the depths of the Hydra constellation, thousands of light-years away. The speed of its movement isn't just unusual, it's theoretically impossible for a structure of its size. Even if it were propelled by some unseen force, like a galactic-scale shockwave, the energy required to fling it across such distances would be staggering. Yet there it is, drifting through the cosmos like a feather on the solar wind. Then there's the question of composition. When telescopes do catch the mirage in action, its light-bending effects are unmistakable, but they don't match any known type of interstellar matter. It doesn't scatter light like dust or glow like ionized gas. Instead, it warps spacetime in a way that suggests something far stranger, a localized distortion, as if space itself has developed a temporary flaw. Some theorists propose it could be a rogue dark matter filament, a thread of the universe's invisible scaffolding torn loose from its cosmic web. Others wonder if we're witnessing the aftermath of a quantum tunneling event, where an entire cloud momentarily phases through dimensions we can't perceive. But perhaps the most tantalizing clue lies in its flickering nature. The mirage doesn't just move, it pulses, dimming and brightening in a way that hints at an internal rhythm. Could it be cycling through states of existence, popping in and out of our reality like a ship breaching the surface of an ocean? Or is it something even more profound, a natural hologram, a projection from somewhere else in the universe, flickering into view when conditions align? Every time scientists think they've pinned it down, the celestial mirage slips through their fingers, leaving behind only questions and a trail of warped starlight. One thing's certain, this cosmic trickster is more than just a scientific curiosity. It's a challenge to our understanding of permanence itself. If an object this vast can appear and vanish at will, what else might the universe be hiding in plain sight? The mirage doesn't just bend light, it bends our perception of reality, reminding us that some mysteries aren't meant to be solved, only witnessed. The quantum veil doesn't just bend light, it turns physics inside out. Floating in the quiet expanse between galaxies, this eighth cosmic fog cloud behaves less like an interstellar haze and more like a lab experiment blown up to cosmic proportions. Here, photons don't follow a single path, they split, as if space itself becomes a quantum obstacle course where light particles exist in multiple states at once. It's the kind of phenomenon scientists usually recreate with carefully controlled lasers and mirrors, not something you'd expect to find drifting through the void like a celestial specter. What makes the quantum veil so extraordinary is how it mirrors the bizarre rules of the quantum world, but on a scale that defies logic. In laboratories, we've seen particles exist in superposition, occupying multiple positions until measured. But the veil takes this principle and stretches it across light years. Telescopes capturing starlight filtered through this cloud detect interference patterns, the telltale fingerprints of light waves canceling each other out, as if each photon traveled two contradictory paths simultaneously. The implications are staggering. If quantum behavior can manifest on this scale, it could mean the universe is far stranger, far more interconnected than we ever imagined. Then there's the mystery of its structure. Most cosmic clouds scatter light randomly, but the quantum veil seems to choose how to distort it, as if guided by some unseen quantum logic. Some researchers suggest it might be threaded with exotic matter particles that only interact weakly with normal forces, creating a sort of cosmic double slit, where light behaves both as a particle and a wave. Others propose an even wilder idea, that the veil is a natural quantum computer, its fog-like structure processing light in ways that resemble qubits flipping between states. Could this be a glimpse of how quantum mechanics operates when unshackled from earthly labs, playing out across the vastness of space? But the most tantalizing question isn't just how the veil works, it's why. Is this a fluke, a rare alignment of conditions that lets quantum weirdness shine on a galactic stage? Or is it a sign that the universe is fundamentally quantum at every scale, with effects we've only begun to notice? The veil doesn't just challenge our understanding of light, it blurs the line between the tiny and the immense, suggesting that the rules governing atoms might also shape the cosmos. And as we peer deeper into its shimmering depths, one thing becomes clear: the universe isn't just stranger than we imagine, it's stranger than we can imagine. The harmonic glow doesn't just warp light, it sings. Nestled between the spiraling arms of a distant galaxy, this ninth cosmic fog cloud pulses with a rhythm so precise, it's as if the universe itself has composed a symphony. Unlike the chaotic distortions of other cosmic fogs, the harmonic glow bends starlight in smooth, undulating waves, perfectly timed to a faint but unmistakable hum, a deep, resonant frequency detectable only in radio waves. It's not just a cloud, it's a celestial metronome ticking away with eerie consistency in the silent void of space. What makes this phenomenon so mesmerizing is the harmony between its light-warping effects and its emissions. Most cosmic structures emit random noise, the static of particles colliding or magnetic fields twisting. But the harmonic glow's hum follows a clear, repeating pattern, almost like the vibrations of a tuning fork struck on a galactic scale. When astronomers first detected this rhythm, they assumed it was interference from a nearby pulsar, but the source was unmistakably the cloud itself, pulsing once every 47 hours without fail. No known natural process explains this kind of precision. Even black holes with their predictable accretion disks don't keep time this flawlessly. Then there's the question of what's causing the resonance. Some theorists suggest the cloud could be interacting with dark matter in a way we've never observed, perhaps a halo of invisible particles oscillating in unison, their collective motion warping spacetime like ripples on a pond. Others propose something even more exotic, a cosmic string, a hypothetical defect in spacetime left over from the Big Bang, vibrating like a plucked guitar string and sending shockwaves through the surrounding gas. But the most tantalizing idea, that we're hearing the echo of a higher dimensional phenomenon, a vibration spilling into our universe from a realm we can't perceive. What's truly unsettling, though, is the implication of that rhythm. Nature thrives on chaos, stars explode, galaxies collide, and particles jostle at random. Yet here, in the depths of space, sits a structure moving to an invisible beat. Could this be evidence of some universal order we've yet to uncover? Or is the harmonic glow a freak occurrence, a fleeting alignment of forces that will vanish as mysteriously as it appeared? For now, it remains a cosmic concert with no conductor, a melody without an instrument, and one of the most hauntingly beautiful mysteries the universe has ever composed. The Prism Void doesn't just bend light, it unravels it. Floating in the emptiness between constellations, this 10th cosmic fog cloud acts like a celestial prism, splitting starlight into razor-sharp spectral bands with uncanny precision. But here's the catch. Prisms work by slowing light through dense materials like glass or crystal. The Prism Void, though, it's an ethereal wisp, so diffuse that a single hydrogen atom might drift for miles before bumping into another. There's no medium to refract the light, no gas, no dust, no exotic matter, just pure, inexplicable dispersion, as if space itself has learned to break light apart with invisible hands. What makes this phenomenon so bewildering is how cleanly it separates wavelengths. On Earth, rainbows form when sunlight scatters through raindrops, a messy but predictable process. The Prism Void, by contrast, produces spectral lines so precise they rival laboratory-grade optics. Astronomers first mistook its output for artificial interference, maybe a satellite's reflection or a flaw in their instruments. But the pattern held across multiple observations, revealing something far stranger. A natural structure in space that shouldn't exist, splitting light with the precision of a master jeweler cutting diamonds. Theories abound, but none fully explain the void's behavior. Some suggest it could be threaded with topological defects, wrinkles in spacetime left over from the universe's earliest moments, where the very rules of electromagnetism might bend. Others propose a radical idea, that we're seeing quantum entanglement on a cosmic scale, where photons passing through the cloud become linked across vast distances, their properties synchronizing to create the illusion of refraction. A handful of daring researchers even speculate about naked singularities, black holes without event horizons, whose gravitational lensing could, in theory, mimic prism-like effects. Yet the most haunting possibility is that the Prism Void isn't refracting light at all. Instead, it might be revealing hidden dimensions. In certain string theory models, extra-spatial dimensions could subtly alter how light propagates, creating spectral splits without traditional refraction. If true, this cosmic oddity might be the first visible hint of a reality far more complex than we've imagined, a universe where light doesn't just travel through space, but dances across dimensions we can't yet perceive. One thing's certain, the Prism Void isn't just a scientific curiosity. It's a challenge to the very foundations of optics, proving that even something as fundamental as light can still surprise us. As telescopes probe deeper into its chromatic mysteries, we're left to wonder, is this a quirk of physics we've yet to uncover, or a signpost pointing toward truths far beyond our current understanding? Either way, it's a reminder that the cosmos doesn't just hold answers, it holds questions we haven't even thought to ask. The phantom current doesn't just drift, it surges. Unlike the other cosmic fog clouds that hang suspended in space like ethereal tapestries, this 11th anomaly moves with purpose, carving a winding path through the intergalactic void as if pulled by some unseen tide. Its motion isn't random. It flows in sleek, serpentine ribbons, bending the light of distant quasars into shimmering mirages that ripple like reflections on a cosmic river. But here's what stumps scientists. There's no current to explain it, no galactic winds, no magnetic field strong enough to tug this colossal structure along its eerie journey. It's as if space itself has developed a hidden undercurrent, a force we can't yet measure or name. What makes the phantom current so unsettling is how it defies the rules of motion. In the emptiness between galaxies, objects don't just glide, they're pushed or pulled by gravity, radiation, or the faint drag of interstellar gas. Yet this cloud moves with a fluidity that suggests something far stranger. Its path isn't a straight line but a graceful curve, twisting and looping as if navigating invisible rapids. Some researchers speculate it could be caught in the wake of a dark flow, a controversial theory suggesting entire clusters of galaxies are being tugged toward an unseen mass beyond the observable universe. Others wonder if we're seeing the fingerprints of higher dimensions, a shadow of motion from a realm where space folds in ways we can't perceive. Then there's the light-bending effect. Most cosmic clouds distort light uniformly, but the phantom current warps it dynamically, as if the cloud's motion itself is sculpting spacetime. When telescopes track its path, they catch glimpses of distant galaxies stretched into fleeting, dreamlike arcs, like watching a reflection warp in a flowing stream. This isn't just gravitational lensing, it's lensing with rhythm, a distortion that ebbs and flows with the cloud's mysterious momentum. Could this be evidence of a new fundamental force, one that interacts only with certain structures in space? Or is the current a cosmic fossil, the lingering ripple of an ancient collision between universes in a long-forgotten multiverse? The most tantalizing clue lies in its speed. The phantom current doesn't just drift lazily, it accelerates at intervals, surging forward before slowing again, as if riding waves in the fabric of reality itself. These bursts of motion don't match any known cosmic phenomenon. Dark energy drives the universe's expansion, but it acts uniformly, not in pulses. Some theorists suggest the cloud might be surfing along space-time vortices, hypothetical whirlpools in the quantum foam that underpins reality. Others propose an even wilder idea, that we're seeing the wake of something massive moving through dimensions we can't access, its passage stirring the cosmic fog like a ship cutting through water. Whatever the truth, the phantom current forces us to confront a humbling possibility, that the universe is far more dynamic, far more alive with hidden motion than we ever imagined. It's not just a static stage for stars and galaxies, it's a shimmering, flowing expanse, where even the emptiness between worlds holds secrets we're only beginning to glimpse. And as we chase this phantom through the dark, one thing becomes clear: the cosmos isn't just stranger than we know, it's stranger than we can know. The Time Lag Nebula doesn't just distort light, it plays tricks with time. Unlike the other cosmic fog clouds that bend or scatter light in space, this 12th anomaly stretches the very moment light passes through it, slowing photons down as if they're wading through invisible cosmic molasses. Telescopes pointed at this eerie structure reveal something impossible. Light from distant stars arrives at Earth noticeably later than it should, as if the nebula has its own hidden clock, ticking slower than the rest of the universe. And the strangest part, there's nothing physically there to cause the delay: no dense gas, no exotic particles, just empty space behaving like it's no longer empty. At the heart of this mystery is a fundamental contradiction. Light travels at a constant speed in a vacuum that's one of the pillars of physics. Yet the Time Lag Nebula defies this rule, introducing delays that can last hours, even days, without any detectable medium to explain the slowdown. It's as if space-time itself has thickened within the cloud, creating a pocket where the universe's rules don't quite apply. Some researchers speculate this could be a relic of the early cosmos, a region where the fabric of reality never fully relaxed after the Big Bang, leaving behind a kink in time. Others suggest something even more radical, that the nebula is threaded with slow light fields, hypothetical energy states that interact with photons in ways we've never observed. Then there's the pattern of the delays. They aren't random. Light passing through the nebula's core slows more dramatically than at its edges, as if the cloud has layers of resistance, like an onion with time warping rings. This gradient effect has physicists revisiting Einstein's theory of general relativity, where massive objects warp spacetime, but the Time Lag Nebula does this without the mass. Could it be tapping into dark energy, the mysterious force accelerating the universe's expansion? Or is it evidence of a deeper, hidden property of spacetime, one that only reveals itself under rare conditions? The implications are staggering. If spacetime can locally stretch without mass or energy to trigger it, our understanding of the cosmos might be missing a crucial piece. Imagine a universe where time doesn't flow uniformly, where pockets of altered rhythm exist like eddies in a river, invisible until something passes through them. The Time Lag Nebula might be the first observable example of this phenomenon, a cosmic metronome out of sync with the rest of existence. But perhaps the most haunting question isn't how the nebula works, it's what happens inside it. If time slows for light, does it also slow for anything else? Could an astronaut passing through this cloud experience minutes while years pass outside? We don't know yet. What we do know is that this ghostly structure isn't just bending light. It's bending our perception of reality itself, revealing a universe far more fluid, far more mysterious than we ever dreamed. And with every observation, the enigma only deepens, leaving us to wonder, if time can lag here, what other secrets might the cosmos be hiding in plain sight? The mirror shard doesn't just reflect light, it obeys it. Floating in the depths of the Carina constellation, this 13th cosmic fog cloud behaves less like a wisp of interstellar gas and more like a colossal celestial mirror. When starlight grazes its surface, the cloud doesn't scatter or distort the beams. It throws them back with eerie precision, creating flawless duplicates of distant stars and galaxies, as if space itself has grown a polished face. These aren't the warped, stretched reflections of gravitational lensing. They're crisp, symmetrical, and unnervingly exact, the kind of fidelity you'd expect from a telescope's optics, not a free, floating cosmic haze. What makes the mirror shard so unsettling is the sheer unnaturalness of its reflections. In nature, perfect symmetry is vanishingly rare. Even the most polished surfaces, ice crystals, still water, mineral facets have microscopic flaws that scatter light. But the shard surface, if it even has one, is flawless enough to bounce back light waves without distortion, as if it's been engineered rather than formed. Some astronomers have jokingly called it the universe's vanity mirror, but the implications are anything but light-hearted. If this isn't a freak accident of physics, what could have created it? One theory points to exotic matter. Certain hypothetical particles, like cosmic strings or magnetic monopoles, could theoretically align in ways that create ultra-smooth boundaries in space. If the shard is woven from such material, it might explain its mirror-like behavior. Others propose a more radical idea, that we're seeing a Bose-Einstein condensate on a cosmic scale, a state of matter where particles sync up so perfectly they behave as a single, coherent surface. On Earth, we create these in labs using ultra-cold atoms, but in the depths of space, the conditions would need to be impossibly precise, as if the universe stumbled into the perfect recipe by chance. Then there's the unsettling question of purpose. Natural phenomena don't need to reflect light this perfectly. So why does the shard, a handful of researchers cautiously, reluctantly float the possibility that it might not be natural at all? Could it be a relic of some ancient, advanced civilization's technology, a forgotten cosmic artifact still performing its function eons later? Or is it something even stranger, a window, a portal, or a beacon designed to catch the attention of anyone, or anything looking closely enough? Skeptics dismiss this as wishful thinking, but the shard's precision lingers like a fingerprint on the universe, impossible to ignore. What's certain is that the mirror shard forces us to confront the limits of our categories. We're used to dividing the cosmos into natural and artificial, assuming the line between them is clear. But this cosmic enigma blurs that boundary, reflecting back not just light but our own assumptions, warped and inverted. Whether it's a cosmic fluke or something more profound, one truth remains: the universe doesn't just contain mysteries. Sometimes it holds them up to our faces, daring us to look closer. The dark lens doesn't just hide in the shadows, it becomes them. While most cosmic fog clouds betray their presence with faint glows or scattered starlight, this 14th anomaly is a master of invisibility, detectable only by the ghostly fingerprints it leaves on the light passing through it. Telescopes pointed at this region of space capture no haze, no shimmer, no telltale wisps of gas, just distant galaxies stretched into surreal arcs, as if viewed through a warped pane of cosmic glass. And that's the enigma. The dark lens bends light without revealing a single clue about what's doing the bending. What makes this structure so unnerving is its purity. Gravitational lensing, the phenomenon where massive objects warp spacetime to distort light, requires mass, whether from stars, black holes, or dark matter. But the dark lens exerts no detectable gravitational pull. It's as if the universe has discovered a way to manipulate light without the usual cosmic machinery, bending beams through sheer emptiness. Some theorists suggest it could be a knot of pure dark energy, the mysterious force accelerating the expansion of the universe, somehow concentrated into a lens-like structure. If true, it would be the first direct evidence of dark energy clumping in ways we never predicted, defying the assumption that it's uniformly spread across the cosmos. Then there's the precision of its distortions. Unlike the chaotic warping of other cosmic fogs, the dark lens creates clean, almost mathematical arcs like ripples frozen in spacetime. These distortions align so perfectly that astronomers initially dismissed them as glitches in their data, but repeated observations confirmed a pattern too precise to ignore. Some researchers speculate the cloud might be threaded with phantom fields, hypothetical energy structures that interact only with light, leaving gravity untouched. Others wonder if we're seeing the shadow of a higher dimensional object, its presence in our three-dimensional space manifesting only through its effect on photons. But the most tantalizing possibility is that the dark lens isn't an object at all. It could be a flaw, a crack in the cosmic code where the rules of optics briefly malfunction. Imagine spacetime as a vast sheet of ice, mostly smooth but occasionally marred by hairline fractures. Light passing through these fractures might bend unpredictably, creating lens-like effects without any physical medium. If that's the case, the dark lens might be a rare glimpse into the quantum scaffolding of reality itself, where the universe's underlying geometry briefly falters. Whatever the truth, this ghostly structure forces us to confront the limits of our tools. We're used to studying the cosmos by what it emits: light, radiation, particles. But the dark lens whispers a haunting reminder. Some of the universe's most profound secrets might not emit anything at all. They might simply alter what passes through them, leaving us to decipher their presence like detectives piecing together a crime scene with no fingerprints. And as we peer deeper into its invisible embrace, one question lingers. If something this elusive exists, what else might be hiding in the darkness, bending the cosmos in ways we've yet to imagine? The celestial echo doesn't just absorb light, it answers it. While most cosmic fog clouds scatter or bend starlight, this 15th anomaly plays an eerie cosmic game of catch, swallowing photons only to spit them back out seconds, even minutes later, their frequencies subtly shifted as if filtered through an invisible cosmic instrument. It's not reflection, there's no surface for the light to bounce off. It's not fluorescence, the re-emitted light carries none of the heat or randomness of typical energy release. Instead, the echo behaves like a celestial tape recorder, capturing starlight and playing it back with a delay, warped just enough to sound like the universe's own distorted whisper. What makes this phenomenon so unsettling is the precision of its mimicry. When astronomers first noticed the delayed light signatures, they assumed they were seeing a technical glitch, perhaps an echo in their own instruments. But the pattern held across multiple telescopes, revealing something far stranger. The cloud was remembering light, holding onto it like a cosmic capacitor before releasing it with eerie fidelity. The frequencies aren't scrambled randomly. They're shifted in predictable, almost musical intervals, as if the echo is tuning the light to a hidden harmonic scale. Some researchers compare it to an interstellar bell struck by starlight, vibrating at frequencies we've never before detected in the void. Theories about how this works range from the speculative to the downright revolutionary. One camp suggests the echo might be threaded with quantum memory, material exotic matter capable of briefly trapping photons in entangled states before releasing them. Another proposes that the cloud is a natural resonator, its structure fine-tuned by some forgotten cosmic event to vibrate in harmony with specific wavelengths. But the most radical idea, that we're witnessing a form of cosmic photosynthesis where the cloud absorbs light not as energy, but as information, processing it through mechanisms we can't yet fathom before sending it back into the void. Then there's the haunting question of why. Nature rarely preserves energy so meticulously without purpose. If the celestial echo is storing and altering light, could it be part of some vast, unseen process, a way for the universe to recycle energy or even communicate across time? The delays aren't arbitrary. They cluster around discrete intervals like a pulse. Some astronomers joke that it feels less like a natural phenomenon and more like a signal, as if the cosmos is teaching itself to echo back deliberately. But perhaps the most profound implication lies in what the echo reveals about light itself. We think of photons as fleeting, racing across the universe at breakneck speed until they're absorbed or scattered. Yet here, in this ghostly cloud, light is paused, reshaped, and set free again. It's as if the universe is reminding us that even something as fundamental as light can still surprise us, still hold secrets we've yet to uncover. The celestial echo doesn't just defy physics, it invites us to listen closer, to hear the universe not just as a static backdrop, but as a living, breathing entity with rhythms we're only beginning to discern. And with every pulse of delayed light, it whispers the same tantalizing question. If a wisp of cosmic fog can hold onto starlight, what else might the void be hiding in plain sight? The Gravitilous Mirage doesn't just bend the rules, it erases them. Floating in the depths of the Lynx constellation, this 16th cosmic fog cloud pulls off an impossible trick. It warps starlight into elegant arcs, mimicking the effects of a massive gravitational lens. Yet when scientists scan the region for the telltale tug of gravity, there's nothing. No hidden star, no black hole, not even a whisper of dark matter. It's as if the universe has conjured a ghostly hand that bends light without touching it. A cosmic illusionist performing the ultimate sleight of hand. Einstein's theory of relativity has been the bedrock of astrophysics for over a century, teaching us that gravity and the curvature of spacetime are inseparable. Massive objects like stars and galaxies warp the fabric of reality, creating the lensing effects we've come to expect. But the Gravitilous Mirage defies this fundamental principle. Its light-bending power exists without the mass to justify it, like a shadow cast by an invisible object. Simulations run and rerun yield the same confounding result. This cloud shouldn't be able to do what it's doing. Yet there it is, twisting starlight into knots while leaving gravity's ledger perfectly balanced. Theories attempting to explain this anomaly read like the plot of a sci-fi novel. One leading idea suggests the mirage might be a brain shadow, a three-dimensional imprint of an object existing in higher dimensions. Imagine holding a flashlight against a sheet of paper. The light casts a two-dimensional shadow, a simplified version of the real thing. If our universe is like that sheet, the mirage could be the shadow of a four. or five-dimensional structure, it's higher-dimensional mass warping space in ways we can't directly observe. It's a tantalizing thought. What we're seeing might just be the tip of a cosmic iceberg, the rest hidden in dimensions beyond our perception. Then there's the quantum angle. Some physicists speculate the cloud could be a macroscopic manifestation of quantum entanglement, where particles across vast distances influence each other instantaneously. If entangled particles within the mirage are somehow sharing gravitational effects with matter far outside the cloud, it might create the illusion of gravity-free lensing. Others propose an even wilder notion, that the mirage is a temporary flaw in spacetime itself, a glitch in the cosmic code where the rules of relativity briefly fail. But perhaps the most humbling aspect of the Gravitilous Mirage isn't the theories it inspires, it's the questions it leaves unanswered. For centuries, we've relied on gravity as the universe's great organizer, the force that shapes galaxies and pins planets to their orbits. Now, here's a phenomenon that achieves gravity's effects without gravity itself. Does this mean our understanding of spacetime is incomplete? Could there be other, hidden mechanisms capable of bending light, or even rewriting the laws of physics under rare conditions? Every observation of the mirage deepens the mystery. Its distortions aren't static, they shift over time, as if the unseen hand behind them is adjusting its grip. Some days the lensing effect strengthens, other days it weakens like a fading echo. This variability rules out simple explanations, pointing instead to a dynamic, evolving phenomenon, one that might hold the key to unlocking secrets about the universe's true structure. One thing's certain, the Gravitilous Mirage isn't just a curiosity. It's a challenge thrown at the feet of modern physics, daring us to rethink everything we thought we knew. Whether it's a window into higher dimensions, a quantum anomaly writ large, or something beyond our current imagination, this cosmic enigma proves one undeniable truth: the universe still has miracles up its sleeve. And as we stare into its light-bending depths, we're left to wonder, if gravity can be mimicked without mass, what other laws of nature might be waiting to be broken? The Starborn Vale doesn't just drift through space, it breathes with it. Nestled among a cradle of newborn stars in the Orion Arm, this 17th cosmic fog cloud pulses and shifts in eerie sync with the stellar nursery around it. Unlike the static distortions of other cosmic fogs, the Vale's light warping effects evolve over time, as if it's somehow tuned to the rhythms of star formation itself. When the young stars flare, the Vale's distortions intensify. When they dim, the cloud's grip on light relaxes. It's a cosmic dance no one expected, a wisp of fog moving to the beat of stellar heartbeats. What makes this phenomenon so extraordinary is its precision. Star formation is messy, violent bursts of radiation, chaotic magnetic fields, and swirling protoplanetary debris. Yet the Starborn Vale responds to this chaos with almost orchestral grace, its distortions mirroring the cluster's growth like a shadow puppet mimicking its master. Telescopes tracking the region have captured something unprecedented. As the stars mature, the Vale's light-bending patterns subtly refine, as if learning from the celestial bodies it surrounds. Some researchers compare it to a cosmic tuning fork, resonating with frequencies emitted during stellar birth. Others see something far stranger, a feedback loop between star and fog, where one shapes the other in ways we've yet to comprehend. Theories about this symbiotic relationship range from the poetic to the revolutionary. One camp suggests the Vale could be a star cocoon, a remnant of the dense molecular cloud that birthed the cluster, now lingering like a ghostly afterimage. In this scenario, its distortions might simply be echoes of the original collapse that formed the stars, a fossil imprint of creation itself. But skeptics point out a flaw. most stellar nurseries disperse their birth clouds within millions of years, blown away by stellar winds. The Starborn Vale, by contrast, persists, its structure seemingly reinforced rather than eroded by the star's radiation. That's where the wilder theories take hold. Could the Vale be harvesting energy from the stars, using their light and heat to sustain itself? Spectroscopic analyses reveal trace elements within the fog metals and silicates typically forged in stellar cores, hinting at a two-way exchange. Some astronomers even speculate about a form of cosmic symbiosis, where the cloud's distortions somehow stabilize the star-forming region, preventing premature dispersal. Imagine a celestial feedback system where stars and fog collaborate unconsciously to extend their mutual survival. It's a breathtaking idea, one that blurs the line between astrophysics and something almost biological. Then there's the haunting question of intentionality. Natural processes don't need purpose, yet the Vale's behavior feels eerily coordinated. Its distortions don't just react to the stars, they anticipate shifts in stellar activity, adjusting before the light from a flare even reaches the cloud's outer layers. This has led a small but vocal minority to propose an even more radical idea, that the Starborn Vale isn't just a byproduct of star formation, but a participant in it. Could certain cosmic fogs play an active role in shaping stellar evolution, guiding the birth of stars like unseen midwives of the cosmos? Whatever the truth, the Vale forces us to confront a humbling possibility that the universe is far more interconnected than we ever imagined. We're used to thinking of stars as solitary giants, forging their destinies in isolation. But here, in this shimmering fog, we see hints of a deeper dialogue, a conversation between matter and light that's been unfolding since the first stars ignited. And as we watch this celestial ballet, stars twirling, the Vale swaying in response, we're left to wonder, if a wisp of cosmic fog can dance with newborn suns, what other unseen partnerships might be hidden in the darkness, quietly shaping the cosmos as we know it? The frozen light doesn't just bend the rules of physics, it shatters them. Photons entering this 18th cosmic fog cloud don't zip through at their usual breakneck pace of nearly 300,000 kilometers per second. Instead, they crawl as if wading through an invisible cosmic syrup, their speed dropping to a fraction of what Einstein's theory of relativity demands. It's as if someone hit a universal pause button, trapping light in a state of suspended animation. And here's the kicker, this isn't happening inside a dense star or some exotic material. The frozen light's environment is as close to a perfect vacuum as space gets emptier than the void between galaxies. So why, then, does light behave as if it's struggling through molasses? At the heart of this mystery is a fundamental contradiction. Light's speed in a vacuum is supposed to be the universe's ultimate speed limit, unchanging and unbreakable. Yet within this cloud, photons dawdle, their journey stretched like taffy. Scientists first dismissed the observations as instrument error, maybe cosmic rays interfering with detectors or an unaccounted-for magnetic field. But when multiple telescopes, including the ultra-precise James Webb, confirmed the slowdown, the implications became impossible to ignore. The frozen light isn't just a curiosity, it's a cosmic rebel, flouting one of physics' most sacred constants. One radical theory suggests the cloud might be saturated with an undiscovered form of matter, one that interacts with light in ways we've never seen. On Earth, we can slow light dramatically using ultra-cold Bose-Einstein condensates or dense crystal lattices. But those require extreme conditions, temperatures near absolute zero or pressures found deep within planets. The frozen light, by contrast, exists in the frigid but otherwise unremarkable depths of interstellar space. Could it be laced with quantum treacle, a theoretical medium where photons couple with exotic particles, trading speed for some strange new behavior. Or is this a glimpse of photonic crystals, on a cosmic scale, structures so finely tuned they bend light's properties without bending its path? Then there's the eerie consistency of the effect. The slowdown isn't random. Photons of all wavelengths, visible light, radio waves, X-rays, all decelerate by the same precise factor, as if the cloud imposes a universal speed limit of its own. This rules out simple scattering or absorption. Instead, it hints at a deeper, more fundamental interaction, one that might involve the very fabric of spacetime. Some theorists point to variable speed of light models, controversial ideas suggesting light speed wasn't always constant in the early universe. If remnants of that primordial physics linger in pockets like the frozen light, it could rewrite our cosmic origin story. But perhaps the most mind-bending possibility is that we're seeing light entangled with itself. Quantum entanglement famously links particles across vast distances, but could photons within the cloud be entangled in a way that creates collective drag? Imagine a school of fish swimming in perfect sync, their coordinated movements slowing the entire group. If light inside the cloud behaves similarly, it might explain the uniform slowdown without violating relativity's core tenets. The frozen light doesn't just challenge textbooks, it dares us to reconsider what light is. For centuries, we've treated photons as simple, weightless messengers racing through the void. But this cosmic enigma suggests light might have hidden depths, ways of interacting with the universe that defy our neat categorizations. And as telescopes probe deeper into its icy grip, one thing becomes clear: the universe isn't just stranger than we imagine. It's stranger than we can imagine, holding mysteries that flicker at the edge of understanding, waiting to be unraveled. The phantom vortex doesn't just distort light, it spins it into a cosmic whirlpool. Unlike the other enigmatic fog clouds drifting silently through space, this 19th anomaly churns with a slow, hypnotic rotation, warping starlight into spiral patterns that resemble galaxies caught in a celestial blender. The effect is eerily similar to the gravitational lensing around black holes, where light twists into fiery rings as it plunges toward the event horizon. But here's the catch: the phantom vortex isn't dense enough to pull off such a feat. It's a wispy, almost delicate structure, less like a cosmic predator and more like a ghostly dancer, pirouetting through the void with impossible grace. What makes this vortex so baffling is the sheer elegance of its motion. Most cosmic rotations, spinning stars, swirling galaxies, even whirling nebulas, are driven by gravity or momentum, their movements dictated by mass and velocity. The phantom vortex, though, spins without any obvious force behind it. Its rotation is smooth, deliberate, as if space itself has developed a gentle current, tugging the cloud along like leaves caught in a slow-moving river. Some researchers speculate this could be evidence of a spacetime knot, a theoretical tangle in the fabric of reality where the usual rules of motion don't apply. Imagine twisting a bedsheet until it forms a tight loop. The phantom vortex might be the cosmic equivalent, a region where space has knotted itself into a self-sustaining whirl. Then there's the light-bending effect. Unlike the chaotic warping of other cosmic fogs, the vortex's distortions are precise, mathematical. Light passing through it doesn't just bend its spirals, tracing out graceful corkscrew patterns that astronomers have compared to the grooves of a vinyl record. This level of order is unheard of in natural phenomena, especially from something as diffuse as interstellar gas. One theory suggests the cloud might be threaded with vortex filaments, hypothetical strands of dark energy that twist spacetime like invisible ropes. If true, the vortex could be a rare glimpse into the hidden scaffolding of the universe, where energy flows in currents we've yet to map. but the most tantalizing clue lies in its stability. Most cosmic whirlpools, like accretion disks around black holes, are turbulent, violent places where matter churns and collides. The phantom vortex, by contrast, maintains its structure with eerie calm, its rotation unchanging over decades of observation. This isn't just unusual, it's almost unnatural. Some theorists wonder if the vortex is a relic of the early universe, a frozen ripple from the Big Bang that never fully dissipated. Others propose something even more radical, that we're seeing the fingerprint of a higher dimensional object, its rotation in our three-dimensional space, just a shadow of a more complex motion happening beyond our perception. Whatever the truth, the phantom vortex forces us to confront a humbling possibility, that the universe isn't just stranger than we know, but stranger than we can know. Here, in this ghostly whirlpool, light dances to a rhythm we don't yet understand, and space itself might be knotted in ways we've yet to imagine. It's a reminder that even in the vast, ordered cosmos, there are still pockets of mystery, places where the rules bend, twist, and sometimes, just maybe, unravel entirely. The quantum foam doesn't just distort light, it flickers with the heartbeat of the universe itself. Unlike the other cosmic fog clouds that warp starlight in predictable arcs or steady pulses, this 20th anomaly crackles with chaotic, ever-shifting distortions, as if spacetime here has been stretched thin enough to reveal its quantum underpinnings. Imagine staring into a pool of water so violently churning that you catch glimpses of individual molecules colliding, except here, the pool is the fabric of reality, and the turbulence unfolds across light years. This isn't just lensing, it's spacetime itself seemingly unraveling into a froth of probability and uncertainty, a phenomenon physicists once thought could only exist at scales a trillion times smaller. What makes the quantum foam so revolutionary is its eerie resemblance to theoretical predictions about the universe's smallest scales. According to quantum mechanics, empty space isn't truly empty. It's a seething, bubbling foam where particles wink in and out of existence too quickly to measure. These fleeting fluctuations are the ghosts of quantum gravity, hints of a deeper reality where space-time isn't smooth but fractured, like the surface of an endlessly boiling ocean. Until now, this quantum foam was purely hypothetical, far too minuscule to observe directly. But the quantum foam cloud behaves as if someone took that subatomic chaos and blew it up to cosmic proportions, offering a front-row seat to the universe's most fundamental turbulence. The implications are staggering. If this cloud truly magnifies quantum-scale behavior, it could be the first observable bridge between the infinitesimally small and the astronomically large, a Rosetta Stone for unifying quantum mechanics and general relativity. One moment, light passing through the cloud might bend sharply to the left. The next, it's twisted into knots or split into phantom duplicates, as if spacetime itself can't decide on a single path. Some researchers compare it to watching static on a cosmic television screen, the interference patterns hinting at hidden channels of reality. Others see something even more profound, evidence that the universe's fabric isn't just warped in places, but fundamentally fuzzy, its smooth curves dissolving into probabilistic chaos under the right conditions. Yet the mystery deepens when you consider the cloud's location. It doesn't hover near black holes or neutron stars where extreme gravity might fracture spacetime. Instead, it drifts in an unremarkable patch of the Orion Cygnus arm, a region with no known cosmic oddities. This raises a haunting question. Is the quantum foam a rare window into universal physics or a freak accident? A cosmic magnifying glass focusing quantum noise into visibility. Some theorists suggest it could be a defect in spacetime's structure, a remnant of the early universe's violent expansion frozen into permanence. others propose that dark matter, if it interacts in unexpected ways, might be stirring the quantum soup beneath the cloud's surface, amplifying effects normally invisible to our instruments. Then there's the tantalizing possibility that we're seeing something entirely new, a state of matter or energy that exists only under conditions so rare. The quantum foam is the first example we've stumbled upon. Picture a cosmic superconductor where spacetime's usual resistance to quantum effects drops to zero, allowing the foam to bubble up into the macroscopic world. If true, this cloud might not just be a curiosity, it could be the key to unlocking technologies that harness quantum gravity, bending reality in ways we've only dreamed of in science fiction. But perhaps the most humbling aspect of the quantum foam isn't the answers it offers, it's the questions it forces us to confront. For decades, physicists have struggled to reconcile the orderly, deterministic world of general relativity with the probabilistic frenzy of quantum mechanics. Now here's a phenomenon that embodies both, a cosmic Rorschach test where every observation reveals new layers of complexity. Is the universe fundamentally smooth or fractured? Ordered or chaotic, the quantum foam whispers that the truth might be all of these at once, a reminder that reality, when examined closely enough, refuses to fit into neat categories. And as telescopes probe deeper into its shimmering depths, one thing becomes clear: the cosmos isn't just stranger than we imagined. It's stranger than we can imagine, revealing its secrets one flickering, foam-flecked photon at a time. The celestial ripple doesn't just bend light, it makes the universe itself seem to shiver. When starlight passes through this 21st cosmic fog cloud, it doesn't simply warp or scatter. Instead, the beams undulate in perfect concentric waves, as if space has turned to liquid and someone has dropped a stone into its depths. These ripples aren't the chaotic aftermath of a supernova or the telltale spirals of colliding black holes. They're smooth, rhythmic distortions pulsing outward like the rings on a pond, except here, the pond is the fabric of reality, and the stone is something we can't see. What sets this phenomenon apart is its uncanny resemblance to gravitational waves, the ripples in spacetime first predicted by Einstein and finally detected a century later. But there's a crucial difference. Gravitational waves are born from cataclysmic events, the universe-shaking mergers of neutron stars or black holes. The celestial ripples' undulations, though, emerge from utter stillness. No nearby collisions, no hidden cosmic crashes, just this serene, ghostly pulsing, as if space itself has developed a heartbeat. Some astronomers describe it as watching a silent film of waves crashing on a shore, except the ocean is made of space-time, and the tide is pulled by forces we've yet to name. One theory points to dark matter. If certain types of dark matter particles interact weakly with ordinary matter, they might form vast, invisible structures that vibrate like cosmic drumheads. The ripple could be the aftermath of such a vibration, a dark matter ping echoing through the cosmos, its waves briefly surfacing in the visible universe as light distortions. Others suggest something even more exotic, a knot in the quantum field's underlying reality, unraveling in slow motion. Imagine plucking a guitar string so massive it spans light years. The celestial ripple might be the resonant hum of that string, vibrating at frequencies we're only beginning to detect. Then there's the eerie timing. Unlike gravitational waves which race across the universe at light speed, the ripple's undulations move slower, as if space-time itself has thickened here. This has led a handful of theorists to propose a radical idea that we're seeing evidence of a higher dimensional event. In some models of string theory, collisions between brains' hypothetical membranes of reality could send shockwaves through our dimension, creating ripples without a visible source. If true, the ripple might be a shadow of a collision happening in a realm we can't perceive, its aftershocks lapping against our universe like waves from a distant shore. But perhaps the most haunting possibility is that the ripple isn't an echo at all. It could be a message. The wave patterns aren't random. They repeat at intervals too precise to dismiss as coincidence. Some researchers have even mapped them to mathematical sequences, sparking debates about whether we're glimpsing a natural cosmic rhythm or something more deliberate. Skeptics call it pareidolia, the human tendency to find patterns where none exist. Yet the ripple's consistency lingers, a whisper in the data that refuses to fade. Whatever its origin, the celestial ripple forces us to confront a profound truth. The universe isn't just a static stage for stars and galaxies. It's a dynamic, ever-shifting medium, capable of vibrating in ways we've barely begun to understand. And as we watch light dance across these unseen waves, we're left to wonder, are these ripples the traces of hidden physics, the fingerprints of dimensions beyond our own, or simply the universe's way of reminding us that even emptiness can hold motion, music, and mystery? The ghostly halo doesn't just encircle its host galaxy, it frames it like a cosmic wedding ring, a perfect, shimmering loop of warped light suspended in the void. While most gravitational lenses distort starlight into messy arcs or smears, this 20-second cosmic fog cloud bends photons with geometric precision, crafting an optical illusion so flawless it looks engineered. The galaxy at its center, a modest spiral similar to our Milky Way, simply doesn't possess the mass to create such a symmetrical lens. It's as if space itself has decided to drape the galaxy in an otherworldly veil, one that follows rules we've yet to decipher. What makes the ghostly halo so unsettling is its mathematical purity. Natural phenomena rarely produce perfect circles, galaxies spin into loose spirals, planets bulge at their equators, and even black holes' event horizons warp under rotation. Yet here, against all odds, sits a structure so precise it could have been drawn with a celestial compass. When astronomers first spotted the halo in 2021, they assumed their instruments had glitched. But as more telescopes trained on the region, the truth became undeniable. This ring wasn't an error. It was an enigma, one that straddles the uncomfortable border between the natural and the artificial. Theories about its origin split sharply between the mundane and the extraordinary. Mainstream astrophysics suggests the halo might be a dark matter corona, an invisible cocoon of the universe's most elusive substance wrapped so tightly around the galaxy that it amplifies lensing effects. If dark matter clumps in just the right configuration, something like a spherical shell, it could, in theory, bend light into a ring without the galaxy itself providing enough gravity. Skeptics counter that such a perfect arrangement defies probability, calling it cosmic taxidermy, a universe stuffing its own anomalies into implausibly neat shapes. Then there's the fringe and far more tantalizing hypothesis. The halo's symmetry mirrors theoretical Dyson rings, megastructures proposed by physicist Freeman Dyson as markers of advanced civilizations. Imagine a swarm of energy collecting satellites orbiting a star, arranged so precisely they'd bend light predictably. While no scientist seriously claims the ghostly halo is proof of aliens, its uncanny geometry has sparked quiet debates. Could certain natural processes mimic the artifacts of intelligence? Or, more provocatively, might nature and technology converge at scales we've yet to imagine? Adding to the mystery is the halo's stability. Most lensing effects fluctuate as stars and gas clouds move within galaxies. But this ring holds its shape across decades of observation, as if locked in place by some unseen anchor. Some researchers speculated could be threaded with topological defects, cracks in spacetime's fabric left over from the universe's fiery birth. These defects, if structured just so, might act like cosmic molding, shaping light into perfect curves. Others wonder if we're seeing a quantum echo, a rare alignment where particles within the cloud entangle across vast distances, creating collective lensing behavior. But perhaps the most profound implication of the ghostly halo isn't what it is, it's what it reveals about our place in the cosmos. For centuries, humans have scanned the skies for signs of order, for patterns that might hint at meaning beyond chaos. Here, in this flawless ring, we're confronted with a pattern so exact it feels intentional, a Rorschach test for the age of astrophysics. Is it a reminder that the universe loves symmetry as much as we do? Or a whisper that some mysteries refuse to fit into tidy categories? The halo offers no answers, only light, bent into a question mark, hanging silently around a galaxy far, far away. The time-warped mist doesn't just bend light, it twists time itself. When astronomers first studied this 23rd cosmic fog cloud, they noticed something impossible. Starlight passing through it arrived either centuries too early or millennia too late, as if the cloud were a cosmic time machine shuffling photons between eras. Imagine shouting into a canyon and hearing your echo return before the sound left your lips. That's the level of paradox this structure introduces to the universe's chronology. What makes this phenomenon so unsettling isn't just the time discrepancies, it's their consistency. Light from stars behind the mist doesn't arrive randomly early or late. There's a pattern, almost rhythmic, as if the cloud pulses between past and future like a pendulum swinging through the ages. One beam might emerge matching its expected arrival date, while the next appears to have journeyed for an extra 1,000 years, its photons bearing the spectral fingerprints of a much older universe. Then there are the outliers, light that seems to predate its own source, as if the mist reached back and plucked photons from a star before it even ignited. Einstein's relativity allows for time dilation near massive objects like black holes, where gravity slows clocks to a crawl, but the time-warped mist exerts no detectable gravitational pull. Its time-bending effects unfold in what should be pristine, unaltered spacetime. Some theorists suggest the cloud could be saturated with closed time-like curves, loops in spacetime where cause and effect tangle into knots. In this scenario, light entering the mist might briefly travel backward along its own timeline before re-emerging, creating the illusion of time jumps. Others propose something even stranger, that the cloud is a knot in the universe's temporal fabric, a relic from the Big Bang when the arrow of time hadn't yet firmly pointed forward. Then there's the haunting question of observation bias. Could the mist be revealing a flaw in how we measure cosmic time? We assume light travels at a constant speed, its journey duration calculable from redshift and distance. But if the mist alters light's speed or path in ways we can't yet model, our entire cosmic timeline might need recalibrating. A handful of radical physicists even speculate the cloud could be a time lens, magnifying fluctuations in the flow of time that normally go unnoticed, like ripples on a pond too small to see until a magnifying glass bends the light just right. But perhaps the most profound implication isn't what the mist does, it's what it suggests about time's true nature. We think of time as a river flowing inexorably forward. The time-warped mist whispers that the river might have eddies, whirlpools, even hidden tributaries winding back upstream. If a wisp of cosmic fog can scramble chronology this dramatically, what other temporal wonders might the universe be hiding? Every photon that passes through this enigmatic cloud carries a message. Time, like light, may be far more malleable than we ever dreamed. The cosmic net doesn't just bend light, it weaves it into a celestial tapestry. Stretching across hundreds of light-years, this 24th cosmic fog cloud warps starlight into a sprawling, interconnected web, linking galaxies like beads on an invisible string. Unlike the chaotic distortions of other cosmic fogs, the net's patterns are deliberate, almost architectural, a labyrinth of luminous threads crisscrossing the void with geometric precision. It's as if the universe itself has spun a spider's silk from spacetime, crafting a structure so intricate it defies every known law of physics. What makes this phenomenon so extraordinary is the sheer scale of its organization. Gravity can create filaments between galaxies, but those are messy, clumpy affairs, cosmic scaffolding built from dark matter and chance. The cosmic net, by contrast, is eerily symmetrical, its strands uniform in thickness and spacing, as if guided by an unseen blueprint. When astronomers first mapped its structure, they assumed they were seeing an artifact of their instruments, a glitch in the data. But as more telescopes focused on the region, the truth became undeniable. This was no error. The net was real, and it was threading the cosmos together in ways no model could explain. Theories about its origin range from the mind-bending to the metaphysical. One leading idea suggests the net could be a visible manifestation of quantum entanglement, the bizarre phenomenon where particles remain connected across vast distances, instantaneously influencing each other's states. If entanglement can occur on a cosmic scale with entire galaxies linked through some unseen quantum handshake, the net might be the first observable evidence of this invisible web. Imagine the universe as a vast, shimmering network where every strand hums with hidden connections, particles whispering secrets across the void. Then there's the dark matter angle. Some researchers propose the net could be a shadow of the cosmic web, the invisible dark matter structure thought to underpin the universe's large-scale architecture. Normally, dark matter's gravitational effects are subtle, visible only in the way galaxies cluster. But if certain types of dark matter interact with light in unexpected ways, perhaps through hypothetical dark photons or other exotic particles, the net might be our first glimpse of this hidden skeleton, illuminated by warped starlight. But perhaps the most tantalizing possibility is that we're seeing something entirely new, a force or field that operates on scales we've never before detected. The net strands don't just connect galaxies, they align with cosmic voids, the vast empty regions between galaxy clusters. This has led a handful of theorists to speculate about void energy, a hypothetical repulsive force that might dominate these desolate stretches of space. If the net is somehow channeling or shaping this energy, it could rewrite our understanding of how the universe expands and evolves. What's undeniable is that the cosmic net forces us to confront a humbling truth. The universe might be far more interconnected than we ever imagined. We're used to thinking of galaxies as islands, adrift in an endless sea of darkness. But this shimmering web suggests otherwise. That space isn't just empty, but alive with invisible threads, binding the cosmos together in ways we're only beginning to glimpse. Whether it's quantum entanglement, dark matter's hidden architecture, or something beyond our current physics, the net whispers a single, haunting question. If light can be woven into such perfect patterns, what other secrets might the universe be stitching together just beyond our sight? The dimensional fold doesn't just bend light, it crumples reality like a piece of cosmic origami. When starlight enters this 25th cosmic fog cloud, it doesn't emerge in a single, predictable direction. Instead, beams fan out like rays passing through a fractured prism, appearing to originate from multiple points in space simultaneously. It's as if the cloud sits at the center of an invisible cosmic accordion, with space itself pleated around it, allowing light to take shortcuts through dimensions we can't perceive. What makes this phenomenon so extraordinary is how perfectly it mirrors theoretical models of higher dimensions. String theory, for instance, suggests our universe may have up to 11 dimensions, most curled up too tightly to detect. The dimensional fold behaves as if it's brushing against some of these hidden layers, warping spacetime in ways that shouldn't be possible in a strictly three-dimensional world. Light passing through doesn't just curve, it branches, splitting into paths that appear to ignore conventional geometry. Some photons seem to loop back on themselves, arriving from directions that should be physically impossible relative to their source. The most striking evidence comes from quasars billions of light years away. When their light passes through the fold, telescopes capture duplicate images, not smeared or distorted like gravitational lensing, but crisp and distinct, as if viewing the same object through multiple windows angled in higher dimensional space. One image might appear where expected, while another materializes 30 degrees off, with no intervening mass to explain the redirection. It's akin to seeing a flashlight beam through a frosted glass pane, except the frosting is the very fabric of spacetime, and the light is emerging from folds we can't directly observe. Skeptics argue these effects could stem from an unusually complex distribution of dark matter, warping space in ways that mimic higher dimensions. But detailed gravitational mapping reveals no hidden structures massive enough to produce such dramatic deflections. Others propose the cloud might contain brain remnants, or theoretical fragments of collapsed higher dimensional membranes left over from the universe's birth. If these brains occasionally unfurl within the fold, they could temporarily puncture our three-dimensional space, creating transient portals where light slips between dimensional layers. Then there's the tantalizing temporal component. Some photons passing through the fold arrive out of sequence, blue shifted or red shifted beyond what their travel distance should allow, as if they've taken detours through spacetime itself. This has led a small group of physicists to speculate about bulk shortcuts, hypothetical tunnels through higher dimensional space that could explain the anomalies. In this scenario, the fold might be a rare region where our dimension presses close enough to others for light to briefly hop between them, like a ball bouncing between parallel sheets of paper. The true wonder of the dimensional fold isn't just the anomalies it produces, it's the philosophical door it cracks open. For centuries, we've assumed the universe operates within the three spatial dimensions we experience daily. Yet here, in this shimmering patch of cosmic fog, light behaves as if those dimensions are merely the visible fraction of a far richer reality. Whether the fold ultimately proves the existence of higher dimensions or reveals some new physics altogether, one thing is certain: it's showing us that space, even at its most familiar, might be far more intricate and far more mysterious than we ever dreamed. The eternal glow doesn't just linger, it resists. While galaxies collide, stars explode, and cosmic structures evolve over billions of years, this 26th fog cloud hangs suspended in time, its light-warping patterns identical to those recorded by the earliest telescopes centuries ago. In a universe where change is the only constant, the eternal glow stands as a cosmic fossil, untouched by the forces that reshape everything around it. Its distortions, crisp, unchanging arcs of refracted starlight, look as fresh today as they did when astronomers first sketched them in the age of parchment and ink. What makes this anomaly so extraordinary isn't just its longevity, it's the defiance of physics that longevity implies. Space is never truly still. Even the emptiest voids ripple with quantum fluctuations, and interstellar gas ebbs and flows with the gravitational tides of passing galaxies. Yet the eternal glow remains impervious, its structure so stable that it might as well be encased in celestial amber. Some researchers compare it to a fly trapped in cosmic resin, except in this case, the fly is light years wide, and the resin is an unknown force halting entropy itself. Theories about its origin split along two equally mind-bending paths. One camp argues the cloud could be a relic field, a frozen fragment of the early universe's conditions. In the moments after the Big Bang, the cosmos might have undergone phase transitions, like water turning to ice, that left behind defects in spacetime. If the eternal glow is one such defect, it could be a pocket where the rules of physics locked into an ancient configuration, preserving a snapshot of reality as it existed before the first stars flickered to life. Others propose something even stranger, that the cloud isn't a relic at all, but a region where time itself has stopped. Einstein's relativity permits extreme gravitational fields to slow time to a near standstill near black holes. But the eternal glow shows no signs of such crushing mass. Instead, a handful of radical theorists suggest it might be threaded with timeless matter particles that exist outside the arrow of time as we know it. Imagine a tapestry where every thread runs perpendicular to time's flow. The eternal glow could be the cosmic equivalent, a structure woven from threads that never fray or fade because they don't experience time's erosion at all. Then there's the light. Unlike other cosmic fogs where distortions shift and shimmer, the eternal glow's lensing effects are static, as if etched into the fabric of space. Light passing through doesn't just bend, it bends exactly the same way every time, with no detectable variance over decades of observation. This precision has led some astronomers to dub it the universe's stained glass window, a celestial pane that filters starlight with machine-like consistency. Skeptics argue this could point to an instrumental artifact, but the pattern holds across every telescope trained on it, from Earth-based observatories to deep space probes. Perhaps the most haunting question isn't how the eternal glow persists, it's why. Nature abhors stasis. Equilibrium is a temporary state at best. Yet here, in this quiet corner of the cosmos, a structure defies that universal truth, standing untouched by the chaos around it. Is it a fluke, a cosmic accident so rare we'll never see its like again? Or is it a signpost hinting at deeper layers of reality where time and change operate differently? The longer we study it, the more the eternal glow seems less like an object and more like a message, one written in the language of light and time, waiting for us to decipher its silent, steadfast defiance of the universe's relentless march forward. And so it hangs there, unchanging, a beacon of permanence in an impermanent cosmos. Whether it's a window to the past, a tear in time's fabric, or something beyond our current understanding, the eternal glow reminds us that even in a universe defined by flux, there are still pockets of mystery that refuse to fade, whispers of eternity written in the distortions of ancient starlight. The void's whisper doesn't shout its mysteries, it breathes them into the cosmos, so faintly that its presence was almost missed entirely. Unlike the dramatic distortions of other cosmic fog clouds, this 27th anomaly bends starlight with the gentlest touch, as if space itself is trembling at the edge of perception. Nestled in one of the emptiest regions of the observable universe, where the average density is less than a single atom per cubic meter, the whisper exerts its influence without a single trace of matter or energy to explain it. It's as if the void has learned to speak, its voice a tremor in the fabric of reality, too soft to hear but too precise to ignore. What makes the whisper so unnerving isn't its strength, it's its impossibility. Every other light-bending phenomenon we've discovered, from black holes to dark matter halos, relies on some form of mass or energy to warp spacetime. But this cloud floats in a near-perfect vacuum, a desert of nothingness where the laws of physics insist nothing should be able to bend light at all. And yet, when astronomers train their most sensitive instruments on this patch of sky, they catch glimpses of distant stars flickering ever so slightly out of place, their light nudged off course by something we can't see, measure, or even define. It's like watching shadows move in an empty room, their dance defying every rational explanation. Theories about the Whisper's origins flirt with the edge of known physics. One leading idea suggests it could be a quantum fossil, a remnant from the universe's earliest moments when spacetime itself was a seething foam of virtual particles popping in and out of existence. If a fragment of that primordial chaos survived, a knot of distorted spacetime frozen into the cosmic background, it might explain the Whisper's subtle but persistent lensing. Others propose something even more radical, that we're seeing the gravitational echo of a parallel universe brushing against our own, its presence detectable only through the faintest warping of our light. Imagine two soap bubbles barely touching. The distortion where they meet would be invisible to the naked eye, but under the right conditions, you might catch the light bending just so. Then there's the haunting timing of its effects. The Whisper's distortions aren't constant. They pulse, fading in and out over decades, as if the cloud is breathing in sync with some cosmic rhythm we can't perceive. Some researchers compare it to the universe's heartbeat, a slow, steady thrum of spacetime itself. If true, it could mean the void isn't empty at all, but alive with hidden vibrations, a symphony of quantum fluctuations playing out on scales we're only beginning to detect. But perhaps the most profound thing about the void's whisper isn't what it is, it's what it represents. For centuries, we've assumed that to influence the cosmos, an object must be something, a star, a black hole, a particle. The whisper challenges that assumption, suggesting that even the purest emptiness might hold agency, bending light through mechanisms we've yet to imagine. It's a reminder that the universe's greatest secrets don't always announce themselves in supernovas or colliding galaxies. Sometimes they linger in the quietest corners, waiting for us to listen closely enough to hear their faint, elusive song. And as we strain to decipher its whispers, one truth becomes clear. The more we learn about the cosmos, the more we realize how much remains just beyond our grasp, humming in the dark. From the Phantom Veil's impossible gravity-free lensing to the void's whisper-bending light in utter emptiness, these 27 cosmic fog clouds aren't just astronomical oddities, they're cosmic revolutionaries, tearing up the rulebook of physics one enigma at a time. Each one whispers a tantalizing secret about the universe's hidden architecture, from the quantum foam's subatomic chaos writ large to the dimensional fold's flirtation with realms beyond our perception. What unites them isn't just their defiance of expectations, but the way they force us to confront the limits of human knowledge. Every time we think we've mapped the cosmos, these ethereal structures remind us we've barely scratched the surface. Consider the implications. If a wispy cloud like the Gravitilous Mirage can mimic black hole-level lensing without mass, what does that say about our understanding of spacetime? If the time-warped mist can shuffle photons across millennia, how solid is our grasp on causality itself? These aren't just academic riddles, they're clues that the universe operates on principles we're only beginning to glimpse. The Starborn Vale's symbiotic dance with newborn stars hints at unseen feedback loops between matter and energy, while the celestial echo's delayed light signatures suggest spacetime might have memory, a notion that borders on the metaphysical. Yet for all their mystery, these clouds aren't cosmic dead ends. They're signposts pointing toward radical new physics. The Harmonic Glow's precise pulses could unlock secrets about dark matter's vibrational nature. The Prism Void's spectral precision might reveal hidden dimensions folded into reality. Even the silent abyss, that light-eating paradox, could be teaching us about negative energy, a key ingredient for theoretical warp drives and time machines. What feels like science fiction today might become textbook science tomorrow, thanks to these celestial rebels. This is why studying them matters. They're not just celestial eye candy, they're the universe's way of nudging us toward deeper truths. Every anomalous photon, every warped starlight arc is a breadcrumb leading beyond the standard model, beyond relativity, perhaps even beyond our three-dimensional intuition. Cosmic net's sprawling connections might rewrite how we see galaxy formation, while the eternal glow's defiance of entropy could hint at entirely new thermodynamic laws. So what's next? With telescopes like the James Webb and upcoming missions like the Laser Interferometer Space Antenna, we're poised to peel back more layers of these enigmas. Maybe we'll find patterns linking them, or uncover a unified theory that explains why space can warp light without gravity, slow time without mass, and echo starlight without surfaces. Or perhaps, and this is the thrilling part, we'll discover even stranger phenomena that make today's mysteries look mundane by comparison. The cosmos has a way of humbling our certainty while rewarding our curiosity. These 27 fog clouds are proof that wonder isn't just for poets, it's the lifeblood of scientific discovery. As you gaze at the night sky tonight, remember, what we see is just the prologue. The real story is still being written in the warped light and twisted spacetime of these cosmic marvels, waiting for the next generation of starry-eyed explorers to decipher it. The universe isn't done surprising us, and honestly, that's the most exciting